All right, so what is ellipse? Well, if you look to the right here, essentially this oval shape um, is an ellipse. And so I'm going to show you a couple properties of ellipses. I recently went to Salt Lake City, and when I went to Salt Lake City, I visited the Mormon Tabernacle. And that building was built in the 1850s. And here it is. That's kind of a picture of it. It is a picture of it. But its roof was built in the shape of an ellipsoid. So the builder knew the properties of an ellipsoid. So back in the 1850s, there was no microphones or things like that to make sound travel. So what they did, and to get around that, which was kind of ingenious, is create this building where sound bounces off the roof, off the ceiling, and bounces directly to another point. And so here's a picture from the inside of the tabernacle. And you can see that little girl in blue clear on the other side of the church. She is standing in the foci, one of the foci of that elliptical shape. So as she talks, and there she is, I'll point her out there with a little crosshair. So as she talks, her sound is bouncing off of these points on the wall on this perfect curve, and they're traveling directly to me where I'm taking the picture. When she was talking, it actually sounded like she was standing right on top of me, just talking directly into my ear. It was amazing. And so that is kind of an example of an ellipse. And so they're used pretty surprisingly in many areas. And they just kind of come up a little bit of everywhere. So some properties of the ellipse. Now there's lots of different things that we can talk about. And I guess before I get into that, I do want to show you one more thing. And so this is a circle with center A, and I just placed D out here somewhere inside the circle. Now between C and D, I've got a line that represents if I were to fold that circle. And what happens is, as I move C around the circle, let me use my computer mouse. That might be better. Let me cancel that. There we go. So notice as I move C around that circle, I've created this slightly elongated circle or oval shape. Well, that's the ellipse. And so as I make all those folds, that's the shape that would form, where D and A are foci of that elliptical shape. Now, what you can do then is move D. Whoops, I hit the wrong button again. Technical difficulties, here we go. But move D out here to the edge. Now, this is going to give me that's called eccentric ellipse when I do this. Oops. So now when I move this thing around, it makes kind of a beautiful picture. So as I move this thing around, you can see how it's longer and flatter. And I'll give you some of the more technical terms for that here in a second. But A and D are still the foci of that ellipse. So if you're in a building and you were talking, that was something that was in this shape. Hit the wrong button there. As you talk at A, all the sound would bounce and go directly to D. And so that's just kind of some of the reflective properties of it, and kind of a neat little activity that you could do with wax paper if you wanted to. Now, some of the properties of an ellipse and some of the terminology you need. So the narrow width here, it has a center in the very center, and you got an elongated axis here. So these are both axes. This distance is called the minor axis, and we usually label it with a B. And this distance here is the major axis, and it goes all the way to the vertex. These are vertices of the ellipse. And so this one's usually represented as A. And then the foci, that distance, so here's the center, a foci might end up being about here in this particular ellipse. Those foci are a distance of C from the center. Each of them are the same distance. And so to graph this, we have an equation that looks like this. X minus h squared plus y minus k squared, and over a squared and b squared, respectively, equals 1. Now, I said A is the major axis. Well, A can be, you could also have the graph look like this. X minus h squared over b plus y minus k squared over a squared. And this is b squared. That equals 1. So, if your major axis is under the y value, like this one, you have a graph that looks like this. Because your coordinate plane is, here's x value, here's your y value. So your major axis is going to be longer in the y direction. If you have this particular graph, then your ellipse will look something like that. It'll be on its side with the minor axes in the y direction and the major axes in the x direction. So what you can do with this equation is now graph it. And so let me give you an example to kind of help us understand this thing. So if I had, say, the equation x minus 5 squared over 9 plus y minus or plus 3 squared over 6, let's go 25. And this equals 1. All right, so let's say we had this equation of an ellipse. So what we'll do here, let me pull in some graph paper. All right, so what we have here is, first off, if we go back to this general form of the equation, h and k, that is the center of my ellipse. And here you notice h is with the x value, k is with the y value. So this is just a way to translate the ellipse around the xy coordinate plane. So in our case, going up here to this, my h is 5 and my k is -3, because you change your signs as you pull it out of the parentheses. And so we'd have 5, -3 as the center of my ellipse. So we'll go ahead and graph that. So 1, 2, 3, 4, 5, 1, 2, 3. So there's the center of my ellipse. And I'll get rid of that stuff. And again, this is my x value, this is my y value. Now, since the 25 is under the y, right here, we know that our ellipse has a major axis of 5. So you take the square root of that number. Because if you look at our original equation, it's a squared. And a is the length of my major axis. So you have to take the square root of the 25. So I know in the y direction, since it's underneath y, I know that the major axis is 5 up and down from the center. So there's my center. I'll count up 5, 1, 2, 3, 4, 5. Down 5, 1, 2, 3, 4, 5. And those are my two major axes. Now my minor axes, since 9 is underneath the x, that's going to be my minor axes of 3. So we'll go from the center to the right 3, to the left 3, whoops, and now we can draw that ellipse. So essentially, without making a table, you could make a table and be a little more precise with your curve and just plug in points between 2 and, what is it, 2 and 8, looks like. So you could do that, but generally this is good enough. because it's just to understand kind of where that shape is located and somewhat what it looks like. But the most important thing you need to find with this, with any ellipse, we've got our major and minor axes, and not to mention just generally what the shape looks like. The major thing to look for is the foci. Now to find the foci, going back to the original, like HK is my center, and A and B are my major and minor axes. To find my foci, the distance to my foci, at least from the center, we're going to call that C, and that distance is the square root of A squared minus B squared. So you subtract your, like in our case, the 25 and the 9, and take the square root of it. So in our case, our C value for our foci is equal to the square root of 25 minus 9. And this would be 16, square root of 16. So I know my distance C from the center to my foci is 4 units. So if I go to my ellipse and I go 4 units up, 1, 2, 3, 4, there's one foci, and foci always go along the major axes. And so there's the foci of this particular ellipse. And so there's one more thing that we need to find that texts or in order to understand it, there's one more thing you need to discover about the ellipse, and that's the word eccentricity. Eccentricity in our case is going to be C divided by your major axes. The closer to 1 we are, the more stretched out the ellipse is. The closer to 0 we are, the closer to a circle we're going to get. So in this case, our eccentricity is 4 over 5, which in our case that would be 0.8. Okay, so that's a pretty eccentric ellipse. If you had a 0.9, that ellipse might look like this. If you had a 0.1, that ellipse is almost going to be a circle. So eccentricity is also somewhat important for ellipses, obviously. So I apologize for those of you looking for deep understanding of an ellipse with this video. I'm not here to give you that today. This is just what you need to know to get by. So let me quickly run through one more problem. So stop the video and see if you can do this. I only have a minute left, so this is going to be quick. So here you go. The center of this vertex is 1, negative 2. So we go 1, negative 2. So right 1, down 2. Right there's my center. My major axis is underneath the x value, and it's going to be 6. So 1, 2, 3, 4, 5, 6. And left 6 from the center. 1, 2, 3, 4, 5, 6. My minor axis is underneath the y, and it's 4. So the square root of 4 is 2. So you go up 2 and down 2, and there's my ellipse. Now, the last two things we need are the foci and the eccentricity. Foci, the value C, would be the square root of 36 minus 4, which in our case is the square root of 32. And if you take the approximation of that, which is all we really need, which is 5.66. And so your eccentricity, so you would go 5.66, so 1, 2, 3, 4, 5. So about right in here, really close, and right in here, really close. And so your last thing is an eccentricity. Notice how skinny this thing is. It's going to have an eccentricity very close to 1. So 5.66 divided by 6, because that's your major axis. And so our eccentricity is around 0.94. And so there's everything that you're probably going to need to get you started with ellipses. So I hope this helps you. Best of luck. See you next time.